This is the first in a set of 4 videos designed to accompany the Further Mathematics conference session, Getting a Feel for Further Mechanics. In this session, we explored how we might support students who are familiar with the mechanics in A-level mathematics to transitioning to A-level further mathematics. Here are some of the topics that students might encounter in a further mathematics mechanics course. Of course, it will depend on the syllabus that you are following and the options that you take. In this session, we focused on the first 2 concepts, work energy and power, and momentum and impulse, as these are common to all awarding organisations. To begin with, we start with a question whose form would be familiar to a student who had completed A-level mathematics. An A-level mathematics student might solve this using projectiles, by splitting the horizontal and vertical components of the initial velocity and then applying the constant acceleration formula in each case. A student who had studied the mechanics content of further maths might take a different approach. Here we can see the working for the projectiles approach that would hopefully be familiar to a student who has completed A-level mathematics. It is perhaps unnecessarily fiddly, because in order to find the speed of impact, we have to work horizontally and vertically, and then find the magnitude at the end of the calculation. A student who has studied A-level further mathematics might take a different approach. Here we assume the total mechanical energy of the system to be the same at the beginning and at the end, and we apply conservation of energy. Of course we get the same result, and so as we are faced with 2 different possible methods, a sensible question to ask students to reflect on is one of the approaches better than the other? And to consider situations where one of these approaches might not work. There are advantages in each case, and students should be encouraged to make these reflections for themselves and work at choosing the most efficient method for a given case. This will make them more effective problem solvers. Here we can see a key difference between a student who has just studied A-level maths and one who has studied A-level further maths. The more mathematics that students cover, the more strings they will have to their bow and the more different approaches they will have for dealing with problems. The application of conservation of energy is one example of a technique that will be new to students in further mathematics. In the next video, we will look at applying this idea in a practical context.